this is I have never given a robot a name before, but my wife started calling this thing Cutie for obvious reasons. So this is Cutie. I finally have a robot with a name. It is basically, I'm developing my own alternative to ROS. So this is mainly a software project. There are 2 pies on this. Not that I need it for what I'm doing so far, but I want the multiple node thing. And so connected in the same network right now is my MacBook. And also this is actually another Pi. It's all talking Wi-Fi. And so if you watch the big screen, you'll see what the robot sees, which partially explains how rough that is. How hard camera navigation is. And this is what's on the screen is my visualizer. Doesn't want to work, of course. That lets me, well, I don't know what it's doing. I'm not going to worry about it. But this lets me play around. There are, when you play with OpenCV, there are like 200 parameters which are not explained and don't seem to really correlate with life. So I built this tool that lets me just play with all the parameters. It's not doing it, but when I click, this is the image tab. So it's showing me what the camera results, the current file, the ISO, the shutter speed, what format the file's been sending at. If I go to blur, it lets me set the kernel size for the blurring and play with that. And I spent about an hour out in the middle court here on the grass driving around and playing with settings, and I've been doing this nonstop for 18 months, and I was still figuring stuff out. And this robot is Saturday. It will, to some degree or another, be running Robo Magellan. I've mainly been focused on the DIY robocars, and as of now, there's a better than 50-50 chance it'll be running Tabletop Challenge, because this year again, I haven't got my little robot working. But I registered for 2 events for my wife to get a ticket. So so I now have remote control. This lets me watch everything as I walk around. Hopefully it'll be hanging around my neck neatly for the competition. And yeah, so this Sunday, this will be what people use instead of ROS, I think. So that's all I've got. Next up.
Thanks.
Oh, actually, one more thing. If anybody lives in the North Peninsula, I've been volunteering doing STEM things for grammar school kids, maybe 5th grade, up in South San Francisco. End of May, they're doing a thing, and they asked me the evening for parents and kids talking about STEM activities. So I'm going to be there talking about robotics and electronics. If anybody is interested in helping out, I could certainly use more mouths, more hands, more demos.
All right, thanks. Who else has a robot to show? Yeah.
Okay, this is kind of difficult to show because it's so tiny, but I got an idea for an education technology robot. So
why don't you, if you want to sit on the table.
oh, where's the, is there, I thought the camera was up there. All right, so I guess Alton's going to zoom in.
Take the mic, take a mic.
This is slow and exciting. So, so I got this idea for an EdTech robot where it would help kids with ADHD and autism.
Hold the mic right up there.
Help kids with, is this good? Is it not working? Oh man, you totally, now how do I do it?
No, just stick it right in your mouth there.
Okay. How's that?
Yeah.
So anyway, I got an idea for an EdTech product where it would help kids with ADHD and autism be attracted to a toy that they would then socialize around. And I got this idea from watching Spinning Tops. A group of kids that had ADHD we're playing with these spinning tops, and it really brought them together and got them socializing, which is a challenge for ADHD and autism kids. So I got this idea for this tiny robot that would then bring them in, and the robot has a microphone, a distance sensor, Bluetooth, low energy, a buzzer, and an LED, and I thought that could do like a beep language to bring them in. And in the interim, I thought I would go to Maker Faire and sell some beta kits as like hacker toys. It's a Cortex M3, M4, so it has hardware floating points. You can do math and BFTs and SMIMD. And I have an Android app.
Yeah, that's easier. Well done.
There you go.
Yeah, this is different. It's not easy.
Practical.
It can be done though. So I'll show you the Android app. It seems to be on. Maybe we can, let me turn the robot on and I'll just do a quick. So I'll connect to the robot and just do some little demo. So I'm just going to go forward, right out of frame, backward, so right turn, left turn. And I can play with stepping modes, and I got the distance sensor doing a rover mode. See if I can get it in the frame. All right, and then of course stop before it flies off the page. So that's the demo. If you see me at Maker Shed at Maker Faire, and you're a software guy, I know a lot of people here are builders. They're not interested in something pre-built. But if you're a software guy, and I could always use help making this work in the NTech space. So thanks.
Question?
Yeah.
What does it cost to build that? If someone wanted to build a fleet?
I've got the parts right now, and this is through DigiKey, Mauser, batteries and motors from Alibaba. And I laser cut the wheels and sandwich them together and make them really cheap that way, out of styrene, instead of making it a 3D printed. The shell is still 3D printed, but right now I'm talking to $60 for parts, but that doesn't include labor. So the whole idea is I could probably get that way, way down. If I go to quantities 1,000, I can manufacture them in China, then the price just goes way down. And there's still a lot of labor, so there's a lot of stuff to work on. Okay.
Yes. Code needs to be built too, so don't dismiss that as not part of the robot building process.
So basically right now it's just running a sine wave, and I control the amplitude, I can control the speed, so I can slow it down, and I can also control the wavelength. So do I want to do like a really high frequency? Well, no, frequency is sort of spatially, not temporally. So I could just have it flail, or I can, when I get the settings right, it'll really move quite effectively here. And then I can vary that wavelength. That's the snake. Couple things about this. These are standard RC car servos. I could do 4 per Roboterra RoboCore board, and I'm just feeding analog inputs to adjust my parameters for now. I want to put the C. elegans open worm on this guy with sensors, so that we'll actually be running an actual real live neural net copied from a living organism, as opposed to like computer simulation. Sort of it's a simulation of a real brain as opposed to a simulation of a simulated brain. Anyway, the other cool aspect is, since tonight's talks were going to be about open SCAD and other CAD tools. I do a lot of the laser cutting stuff at the Hacker Dojo and Makerspace, so these were both made on laser cutters. The laser cutter of the dojo, this is kind of like a donkey car, just with a box, and then I've got a Pi and Arduino style, RoboCore here that's fairly clean connectivity-wise. So it's just a Fermata connection with Johnny5.js node stuff, controlling that. What else? There's no fasteners here except for on the metal part of the servo, the horn. And I had to do it there, even though the press fit fairly well. I can remove the screw, but they'll start coming loose if I don't have some kind of screw friction there. And these are regular skate bearings that I just put a little heat shrink on for the wheels. So, any questions?
Well, I have a question.
Yes.
Can you make it go forward?
I could make it go forward and backward, but right now not with the code. I mean, I just kind of got this running, and I'm just iterating right now on mechanical. Part of my goal was to actually have it evolve its own kind of strides and gates and stuff, as opposed to, programming a sine wave in manually.